Okay, here's my little robot. It is remote control. I can go forward, left, right, and back. But I can set it to autonomous mode, just like your Tesla car, if I press 1. So once I press 1, the robot can wander on its own without hitting anything. So let's turn it on. It's got to have pretty fresh batteries, otherwise it may not work as well. It's using a lot of sensors and things like that, so on the motors. So make sure that you check your batteries if it's not working. But you can, go left and stop it, go right, stop it, go forward, go back, go left. And you can put it in autonomous mode. So it's gonna wander around by itself. If it does hit something, it'll back away all by itself. You can see that the remote control is there. Hey everyone, I'm very excited to bring you another experiment. This is experiment number 4, and we're going to be learning about infrared remote control. So the basic purpose is to create a program and wire the robot where you use a small remote control to go forward, backwards, left, right, stop. You can make it beep with a button. But the final part of the lab is where you'll be able to do all those things, but also with the press of a button, you can make the robot go from remote control to autonomous mode using a sensor like infrared or sonar. Okay, so why don't I walk you through what we're going to be doing, some of the testing, how to do some of the testings for these things, how to read the values out of the remote control, and we'll be digging into the switch and case statements of programming. Let me show you some of the components real quick. So we have this little remote control here, and it has a lot of buttons. So we'll be using this button for forward, this one for reverse, go right, go left, and then these are all optional buttons that can be programmed. So at the end of the lab, the idea is that you'll be controlling the robot remotely, but also what I would like for you to do is program button number 1 to convert it into autonomous mode, so that you can use this guy to navigate, or you can use this guy to navigate, or both, it's up to you. But the idea is how to go from remote control to, hey, go by yourself now. Okay, now this comes with a little plastic tab over here, and that's basically protecting your battery so it doesn't wear out. So why don't you go ahead and take that off. Okay, so once that's off, the remote control can be used. It also comes with some components. This is the receiver, okay, and the receiver is just a special, let's see if we can, just a special IR receiver LED. See if we can, maybe you gotta get a little closer. Okay, so it's just an IR receiver, and it has, if you look at it carefully, it has, well, I'll show you the photo on the video, on the presentation anyways, but it does have a three wires. It's got the signal, it's got the plus and the minus. You can see the S is on this little corner here. Okay. The kit also comes with this little guy, this LED. This is a transmitter LED. So let's say that you don't want to use a remote control. Okay, you can put this into your breadboard here. Or you can connect it to the breadboard, and you can use that to send signals to this guy. Okay, so now you don't have to use the remote control, but it requires different kind of programming. But it is available to you. You can experiment with that. That way you can for example do 2 robots, and you can put this like in the front here somehow, and you can have the robots try to do some kind of a virtual laser game where this guy is gonna try to shoot the other robot, and then if it hits it in the right place where the receiver is, you can disable it. You can do a whole autonomous game of tanks looking for each other and shooting out, you know, the infrared light, and then the receiver gets it and you can disable the opponent. Similarly, the other guy can shoot you back and those kinds of things. So those are, you know, really neat things that you can do. So here, similar to this, right? Here's the transmitter, and this is the receiver. You can see that it's the same thing. You have the dark cover LED here, IR receiver, and you have the clear transmitter. Same thing with this, right? It's just like having these guys over here. Same thing, except these are really long range. Okay? You can go really far out to do that. So when you place this guy, make sure you place it in a place that you'll be able to, with the remote control, you'll be able to, you know, turn the signal in going into that, so it's not obstructed by anything. Okay, and it comes with 3 wires, so that in case you want to extend it and plug it into someplace else on the robot, you can. But I highly recommend that you can use, in this case, you can just use the breadboard like this, for example, and then you wire the 3 wires over here. Alright, so let's go over what the lab requires, and then I'll start wiring this guy right now. So let's go a little bit more here. So this is the remote. This is, again, you got the negative, the signal, and then the positive in the middle. Again, this is a transmitter LED. Optionally, you can use that later on. And let's see, you can see that it's got all those things. And what it is when you press a button, the signal that comes out of here is a hex value. Okay, it's a hex number. And so the hex number comes in here encoded, right? And then you can convert that number into something else by using case statements, for example. Okay, so it's just a hex value. And infrared means basically the frequency of infrared light that is less than the frequency of red light. Okay, infrared is under the regular light. And some remote controls, like your television remote controls, will have your transmitters of infrared that run at a particular frequency. Most of them run between 30 kilohertz and 45 kilohertz. For example, Sony likes to use 44 kilohertz to send their signals. Okay, so if you buy a Sony remote control and you try to receive signals from it, they'll be at 44 kilohertz. Now, there's something to keep in mind. Some fluorescent lights, okay, like your garage lights or other fluorescent lights that you have, transmit signals at the same frequency you see here. So sometimes the light that you have up there on the ceiling will affect your receiver on your robot. So keep that in mind as you use them. Okay. For this one, we're going to be using libraries because they preload a lot of the things that we need to do, and it just makes it easier. There's a lot of information out there, and of course here's a tutorial how to install libraries. But it's as simple as this. I need to install them on my computer too, so let me do that. So in your folder or your Beach Board, you will have a libraries folder, and basically I'm going to download this to this timers one. We might be using timers again, and this IR remote library. Remember, libraries have all this coding in there. So like this one has all this coding on how to accept signals from all these brands of remote controls, right? So like Sony, for example. Okay, and so a lot of examples in here are really neat, right? How to basically look at the data that's coming in, how to send and receive raw data, and very specific ones for specific remote controls. So lots of neat things that we can play with in here. Again, I'm going to download these two. I'm just going to copy them. And what I'll do is I'll just paste them on my Program 86 folder. x86, and then Arduino. And then right inside the library, I'm going to paste them in there. Okay. Continue, yes. continue, yes. So now that I have them in there, I should be able to use them and use the examples that are in there as well. All right, so let me open up a new Arduino window here. And what I'm going to do now is I'm going to start wiring this this first example here. So basically, again, we just need the negative, the positive, and then a signal. And we're going to be using the analog 0 signal. Okay, so input, analog 0 input. Okay, so the first one is this demonstrates receiving IR codes. And so this one will show a value on the screen depending on the button that you press. So we're using the library irremote.h that we downloaded. I'm going to copy that and I'll explain what the code is doing exactly. Okay, but in the meantime, let's go ahead and wire that circuit over there. And I'm going to also change my preferences because I might want to go a little higher on my font so you can see the code a little better. Okay, so stay tuned. I'm going to wire the circuit now. Okay, so I've wired my sensor. I have my 3 wires going to the back area here of my analog input. And because they're back here, I don't need to turn on my robot power, because this power is for this entire row over here where the motors are. Okay, so I don't need to turn that on. Everything is powered by the USB cable right now to the board for this row. Okay, this is the analog input. And let's go back and look at our circuit again. So I plugged it into that row right here for analog input 0, which is our first analog input. And I just grabbed this code and let's see what the code does exactly. Okay, so I'm using the library and I'm saying that my receiving pin is analog 0. That's where I connected it. And this is based off the library here. I can use this particular functions like the IR receive on the receive pin, decode results. It does decoding automatically. Everything is basically being translated over here. And what do I want to do? I want to show the results on the screen. So let me do our serial begin at 9600. That's our baud rate. And this is our, I want to be able to receive those into that enable IR. These are all again part of the, you don't really need to understand as much this particular functions because they're part of the library. Okay, and you can always look at the documentation for the library to understand what all this means. So if I am decoding, if I'm getting something basically, and let's put in the results in there and let's print them one line at a time. Okay, and we got to make sure that we mask the results with the proper type of data. In this case, these are hex values. If it's a decimal, for example, you can put DEC. If it's just plain text, you don't have to put anything. But in this case, we have to specify, hey, these are hex values. So let's label whatever we show on the screen as a hex. Okay, and then there's a little delay, so it keeps looking for more signals, right? And then it'll try to receive the next value. So let's upload this program. I'm not gonna save it. Okay, it's uploading. Done uploading. Let's open up our little communication port. Let's open up our camera so you can see what I'm trying to do. Alright, so I'm just gonna grab the remote and you point it, let's do this. Looks like I have more here. There you go. I'm just gonna point it here. Now you can go really far with this remote, but if I pointed there and I press 1, for example, you can see on the screen it's giving me this hex value. If I press 2, sometimes sometimes it uses the same value, but let's say 3. Okay, that's a different value. So it gives you a good idea of what the value is for each button. Right, so this is button number 4, 5, 6. Right, and then even like the pound sign, you know, I got the pound sign, for example, and the asterisk. Right, but here you go: forward, left, right. Okay, there's a little debouncing feature because of the way that you press things. And then OK, which is the middle button. So now that you know these values, you can grab these values and use them in a code to basically send signals to the motors to go, hey, if I get this signal, go forward, backwards, left, right. Okay, so there's your first program, how to decode values from there. If you have a TV remote and you can, even if they're at the exact same frequency, you could always decode those values from your TV remote control. Alright, so let's look at another example here. This one right here dumps details of the IR code. And this one does a little bit of the same, except it'll tell you whether you're using a very specific brand of remote control. Okay, so I guess each brand has its own little decoding feature, so the library can do that for you. So if you have a very specific remote for your TV, you can always try it, and then from there you can go ahead and use it for your robot once you know the decoding of it. Alright, so the next one is, let's scroll down here, more decoding and testing. Okay, so this one right here, you can see the raw data plus the button that you're getting. Okay, so this one right here will give you a little bit more information than you need. And oh, this is if you have a very specific remote, and then you can do like channel up, channel down, and those kinds of things. This just gives you, this is a good introduction to how to use the switch statement and how to use a case. But this will be an optional program, because in the next one it will show you how to do all these things. Only if you have a brand name remote to test. Okay, so we're not going to be doing this. This is just for your own information, that this is how we use the switch and case statements to make it do something while we are pressing a specific button. Okay, but let's skip it, because let's do this one. A neat example how to turn an LED. You know that there's an LED connected to pin number 13, right, of the board. So let's try that. Alright, so I've copied and pasted this program into my Arduino sketch area here. If you don't, if when you paste it this doesn't work, what you can do is you can always go here to File and go to Examples and go to the IR remote, and this is the relay example, except that I modified it to change the pin numbers to receive on analog input 0, which is where we plugged in our receiver, and the LED is connected to pin number 13 of the board. It's already built in. And then down here we got to make sure that we change that to also to pin 13 so that it matches our output. Alright, so let's just upload this to the Arduino board. And let's see, I'm outputting something also here. So let's put this guy here. Let's get our camera going here again. And let's look at what happens when I start pressing any of the buttons. So do this one. There's the LED. So you can see the decoded bits over here, and you can also see the raw value. Now I wonder, so this one is accepting anything. So anything that you do will turn the built-in LED on and off over here. So whatever button you do. The neat thing is that it gives you the what the raw value said, and also what the hex values are as well for that particular button. Okay, so on and off. All right, let's continue with some more samples. The next one here is navigating with the IR remote. Okay, so I'm going to give you some of this information because I think it's helpful to understand that. But your job again is going to be to basically make the robot navigate with the remote, but then when you press the number 1 button, it goes into autonomous mode. But let's look at how we can do some music and how we can do remote as well. So let's copy this program. We got a little part of a Mario Brothers song. Okay, we got our speaker connected on pin number 4. We got our even an LED in there. So let's see what happens all the way to here. Hopefully this doesn't give me errors, because sometimes when you copy from a Word document which hides characters, it copies some strange characters in there. So, alright, and I'm going to make this green because this is the require lab. Okay, so let's do this. Let's delete that. Actually, let me save this program. This is the one with the relay. Okay, hold on. Relay with LED, basically, instead of the relay. That way I have an extra example in there. Alright, oh, didn't mean to close it. Let me open a new one again. Okay, what you want to do is, because this is going to overwrite the last one you saved, you want to say new instead. Close that one. So you want to say new. That way you have a blank sketchboard here. And let's upload it and see what happens. Alright, so I don't have my pitches library, so let me look for that real quick. And that should be under my, let's see, I think on the first one I have, yeah, right here. So I have this pitches library on the sample number 1, experiment number 1 has that pitches library, because we learn about sounds in the experiment number 1, but I forgot to put in my pitches library. Alright, so let's look for our program files, x86, Arduino, libraries, and paste that in there. Okay, so this is good. You get to see some of the errors that I go through where I have to remember to put things in a certain place. Alright, let's see what else we find here after compiling this. So compiling sketch. So it looks like we have an LED on pin number 13. We have our speaker connected to pin 4. We have our servo motors as well. And it looks like we have our nice case statement. So let's check this out real quick, and then we'll show you the demo. So we have this loop, and in the loop we're basically looking for a decoded value, a hex value. I already know some of the values of the buttons based on the previous testing that we did. So I'm creating a forward function somewhere down there, and I'm calling it over here. I'm saying if the result is this one, switch to this case statement, and go ahead and perform all these things. Okay, so it's going to basically make some noise, turn an LED on for half a second, and it's going to make the robot go forward and backwards. Actually, this is going to keep beeping, you know, over and over and flashing an LED, and it's also going to make the robot go forward, looks like. So depending on what I'm decoding here, I'm going to make the robot do something. And then we have a stop, and when I press button number 1, I'm going to play the Mario theme song. So let's open up our serial monitor. Let's open up our little guy here, and I'm going to make sure that for this test, before I put it on the floor, I want to test it on the bench. So we're doing a bench test here. Putting a little box underneath it. That way the motors are by themselves. I'm using the motors here, so I want to turn the robot on to turn those motors on. Okay, and let's see what happens when I press number 1. So we got our Mario Brothers song there. Okay, I press 1 again and it stops. Let's press the blue button up. And the robot goes forward. Press it again. Oh, press the button. The middle one is for stopping. Okay, so we can do left, stop, right. And our built-in LED does a little flashing as well. Alright, so after this, and I'll put it on the floor so you can see, but after this, your job is use this guy's, or use this guy, or both, but make button number 1, so control it with the remote, but when you press number 1, it automatically goes into autonomous mode. This will be like you're driving your Tesla remotely, and then you put Tesla into autonomous mode, so your car goes by itself, and then you press a button on the Tesla and say, hey, go by yourself, and then it does it. Alright, so let me show you how it works on the floor, and I'm going to put it on the floor right now, but in the meantime, let's play our little song again. Alright, so let's check this out. Oh, I started again. By the way, you gotta press it at the right sequence, otherwise it won't. You won't make it stop. All right. So let's test our little robot here. Hopefully, it can reach my signal. It's going forward. Stop. Let's go backwards. Alright, make a turn, make the other way, go forward, stop, go backwards, stop, play a song. Okay. And then we have to wait till that loop finishes, for that function for the song finishes, then we can go ahead and go forward again. Okay. For our batteries, make sure that we have at least 1.3 volts per battery here. So we're going to be testing our batteries before we run the next experiment here. I wanted to give you some tips on the programming for the autonomous part when you press button number 1. So especially this part, when you go to the case statement for pressing button number 1, you might want to do a while loop. So while true, then go to an autonomous function that you create. Okay, so I just wanted to let you know that this is how I did it and this is how I got it to work. Do a while loop, and you can do a while is true, go to a autonomous function, and then you put in all your values in the autonomous function. That's all. Okay, here's my little robot. It is remote control. I can go forward, left, right, and back. But I can set it to autonomous mode, just like your Tesla car, if I press 1. So once I press 1, the robot can wander on its own without hitting anything. So let's turn it on. It's got to have pretty fresh batteries, otherwise it may not work as well. Now it's using a lot of sensors and things like that, so in the motors. So make sure that you check your batteries if it's not working. But you can, go left, and stop it, go right, stop it, go forward, go back, go left. And you can put it in autonomous mode. So it's gonna wander around by itself. If it does hit something, it'll back away all by itself. You can see that the remote control is there.